I'm going to start with two conditioners I call chemical conditioners because they add something to the water. First, polyphosphate dosing. I've included this one because it's got two canisters. This has got the polyphosphates in. This one, in fact, is a water filter. It filters the water before it goes into this canister. And I wanted to mention this because if you see something under a sink, and here's one example, this may not be a polyphosphate doser, but a filter, and this one's got a carbon filter inside. There's the black carbon there. And as the water goes through this, it removes impurities, flavours and so on, to give maybe a cleaner tasting water, but it doesn't treat the hardness at all. Polyphosphates are chemicals made from the basic phosphoric acid, H3PO4. Phosphoric acid is regarded as a safe chemical. It's added to Coca-Cola to give it extra flavour. It's put in all water by the water companies to reduce the solvency of lead if there's lead pipe works in their area. You get phosphate by removing H2O, and this can be linked together to form long chains, perhaps hundreds of phosphates long, to make one kind of polyphosphate. The polyphosphate in Calgon has 6 phosphates linked together in a ring like this. Polyphosphates like this, and also the long chains, work by a process called sequestration. In other words, they grab onto the calcium and magnesium ions and they won't let go. So although the ions are taken out of action, as it were, they're still in the water. Polyphosphates are added to the water as the water flows through. It's called the Venturi principle, like this. So as the water flows across here, it actually flows through a constriction of the pipe. This makes the water flow much faster, and as it travels across the top of this canister, it sucks up a little bit of phosphate. So imagine the water shooting past here, taking up some of the phosphate, so this gradually gets used up. It's often called proportional dosing because the faster the water flows through the Venturi, the more polyphosphates are picked up. These polyphosphates are well known in the food industry. They come with an E number of 452 for emulsifiers, thickeners and stabilizers. And the hard water people claim they are safe in the doses involved with their treatments between 2 and 4 milligrams per litre. But my own view is that these additives really have only been assessed in isolation, and the concern these days is the effect of cocktail of these additives in our food and drink. So you may be able to eat individually them by the spoonful, but together they may have a quite different effect, and that's why I personally wouldn't consider polyphosphates. Of course, my concerns may be completely groundless, but I would like to see, for a change, some real evidence rather than all these unsupported claims made by the salespeople. But there's another reason to be wary of polyphosphates. Phosphates are a limited natural resource. The supplies aren't endless, and we can't just carry on putting phosphates into the environment without causing some damage. And just as with sodium of water softening, there are limits. It can't be used by everybody, so ultimately we'll have to find some other solution. The other thing to consider is the maintenance. For instance, the Calphos here say they need replacement of a new cartridge every 40 days for a family of 4 using on average 120 litres a day. Well, it's quite easy to find other figures for national consumption. For instance, the Environment Agency gives the typical 150 litres a day. And of course, individually in your own use may be more than that. 150 litres a day for 4 people would mean that the cartridge needs replacing every 30 days instead of 40 days.
My second kind of chemical conditioner is electrolytic. It's usually referred to as a physical conditioner, but to my mind, as a small amount of chemical in the form of zinc is added to the water, it's really a chemical conditioner.
This is a typical one that's the LIF. It's about 150 to 200 mil long, these things, 15 mil pipe, or 22, you can get them for. The water goes in one end at the other. As it passes through, it washes over a zinc electrode. Now this works by the activity series, that's what it depends on. Here are some metals in the activity series, from potassium, which reacts very violently with water. You may have seen it, a little bit of potassium skating around on the surface of the water, bursts into flames. At the other end, gold and platinum, which won't react at all. What happens when you have two of these metals together in the same pool of water is that the more reactive one will dissolve in the water, and it protects the less active one from reacting. Here's an example. Ships made of steel, which is mostly iron, have chunks of magnesium bolted to the outside, and the magnesium will dissolve, corrode, and protect the steel hull of the ship. Here, what happens is a combination of zinc and copper. It's the zinc which will dissolve, leave the copper intact, and it's the dissolving zinc which has the activity of changing the calcium bicarbonate into aragonite. So during the life of the electrolytic, which will be a matter of years, the zinc will gradually dissolve. And we're talking about a thousandth of a milligram, that sort of thing, compared with the recommended daily allowance of 5 milligrams. That was 5,000 times more. So we're talking very, very, very small amounts of zinc. Because you can't see what's going on inside one of the electrolytics, it's a bit of guesswork as to whether it's still working or not. The CESI says it can last 10 years, but it depends on the amount of water flowing through. If it's a bigger family with more water, more zinc will dissolve, for instance. They also told me that the effectiveness of electrolytics drops off after 350 parts per million of hardness. So I'm really not sure, if you've got really hard water, what effect these will have. Aquabions say theirs will last 7 years, but they'll guarantee 5. What they do say about the way that their one works is that the inside parts stir up the water and keep the electrode clean and working throughout that time. In fact, they say about their competitors that they don't work because their zinc electrodes get clogged with deposits and so on. So I don't know what to make of that. Also, they say that their one is 95% effective. I don't really know what that means. Aquabion, like many of the other conditioning devices, has a commercial application. Here's a very large one in a factory. When it comes to the domestic situation, the evidence they give for their effectiveness in this magazine article, the experiment was run for 14 months, and at the end of it, it says the visible components like shower heads and tap heads and so on were free of limescale. Well, that doesn't tell me what was on the side of the boiler, and it doesn't tell me what it's going to be like in 5 years' time or so. So that's an example of what I mean. The evidence isn't really very good. Aquabion like to take a swing at Calgon as well, because Aquabion supply a little electrolytic you can fit to a washing machine, so they compare their effectiveness with Calgon tablets, which you can put inside your washing, and they think they came out very favourably. However, Consumer Witch have looked at the Calgon tablets and say, well, Calgon did their results with 60-degree washes. Most of us are using 40-degree washes, and you don't need these limescale tablets at all. Do you need the Aquabion electrolytic for your washing machine either? I wonder. Limescale won't form in a cool wash, and at worst you'll get the effects of scum on your clothes, but that'll probably get washed out in a rinse anyway. So it can be very difficult to tell if your electrolytic is still working, especially if the effect is gradually wearing off towards the end of its life. The effects are very subtle. In fact, in terms of shades of subtle, I think some of these come in at number 49. the taps gradually becoming encrusted with scale or shower heads as well. Quite a few of these electrolytics you buy don't have labels on to mark the date when they're installed. Some suppliers like Aquabion, if you register date of installation on the website, they'll send you a reminder when it's time to renew. In fact, Aquabion say that the replacement is cheaper than the first installation. But what seems to be the best one for telling you what's going on is the Sentinel Scale Pro. This one has a battery which powers a light which flashes and tells you that it's operating correctly and releasing zinc into the water. Well, at least that's what they say. Their graph of effectiveness, it looks like this, and you might think from Aquabion, after listening to them, that this is Aquabion and these are their competitors. But no, this is the Scale Pro, and a relative comparison of what they call other leading brands shows 20%, or this must be about 2 or 3% activity or effectiveness compared with their one. I've tried to find out if that includes Aquabion, because they wouldn't tell me. But really, I would expect, as electrolytics are pretty similar in activity, especially when they're new, for reasonably comparable results, maybe 20-30% less, but not as little as this. With a result like this, I would question the investigative technique, not the results in this way. I've talked to Sentinel about their experiment, and they say they measure the amount of zinc that's being released, and really, if the results are correct, one wonders what some of these electrolytics are doing that are being sold in the market. Finally, there are 2 regulations for installation of electrolytics. These are produced by the Water Regulations Advisory Scheme, and these are their code numbers for the 2. The first one says that the electrolytic should be accessible for maintenance and checking and so on. The second one requires a single check valve to be installed in line between the mains stop valve when the water comes into the house and the electrolytic. I thought this was a bit odd, because if the water's safe enough to drink that passes through the electrolytic, why isn't it safe enough if it goes back into the coal main system? I asked the WRAS about this, and they apparently discussed it at a committee meeting and still came out with this requirement, because they say the water's been changed, or had zinc added to it, for instance, so there must be a single check valve. Maybe some of you out there who also think it's very odd, perhaps have more influence, and see if you can get this regulation removed.